Next up is some important circuit vocabulary. Let's start off with a closed circuit. This is where a circuit, and again the root of circuit is circle. Closed circuit has a complete conducting path from the positive to the negative terminal of the power supply, i.e. the conducting path is a complete closed loop. That's why it's called closed circuit. It's not like a door. Here's a picture of a closed circuit. I'm going to draw a battery. I'm going to draw a light bulb right here, and I'll just complete it like that. An open circuit, by contrast, is where the circuit lacks a complete conducting path. Again, this is not like a door nor a water faucet. I've heard many people say, yeah, open that light. Really, when you turn on a light, you are closing the circuit. So careful, it's not like a door that you open to go through. If you want charge to go through something, you've got to close that circuit. And this will not be lit because it's an open circuit. Again, no charge will flow. A short circuit, by contrast with an open circuit, and people do confuse these, but a short circuit is where you have an excessively low resistance path from the positive to the negative terminal of the power supply. Now, how can it be excessively low? Don't you want it low? Well, sometimes you do, sometimes you don't. For example, here's a situation. I've got a battery right here, and I've got a bulb right here, and this bulb will light, no problem, unless I add these wires right here. And now, what's wrong with that? Well, given a choice, if water, you could think of it as water, could flow through a very, very difficult path or a really easy path right there, almost all of it's going to go through the very easy path. In fact, adding these wires right here will cause this light bulb to go out because there'll be a really large amount of current flowing through this wire, and it will tend to bypass that light bulb. An individual element is called shorted out, like this bulb is shorted out if there's an excessively low resistance alternative path around it. Now notice that my short circuit right here, that short is actually a longer path, but it's lower resistance than the bulb. So don't confuse a short circuit with something that's a shorter, in other words, lower distance path. It may not be. It's a lower resistance path. Short circuits are problematic because they can cause very high currents with very low resistance. Using Ohm's law, you can tell that the current will be very high, and this can create excessive heat and or fire. So you really don't want a short circuit, and a fuse is there in case there is a short circuit. A fuse will melt, opening the circuit. An electrical ground is next, and that's a reference point defined as typically 0 volts. You could really make anything your ground if you want. It could also be an object providing a return path for current back to the power supply. We'll see that in a minute. An object which can, another way of saying what a ground is, it's an object which can donate or accept unlimited charge, positive or negative, yet remain neutral, i.e. at V equals 0. So electrical grounds are typically used in something like a car. For example, let's say we have our battery, our car battery right here, and we want to, thing is, you don't want to have to send 2 wires to every single device in your car. It's way easier to just send 1 wire right out here, send it to maybe a light bulb right there, maybe we'll send it to some kind of resistance like a radio, or maybe we'll send it to your starter motor right here. I'm just going to use another resistor right there to represent that load. And then what you do is you connect the negative terminal of the battery to ground, and then you connect all the other negative terminals to ground as well, and they are effectively connected to the negative terminal of the battery. Now notice Sometimes you'll have 3 lines, sometimes 4 lines. It really doesn't matter. It's either one that you choose. But notice that this is equivalent to having all of these loads connected right back to this thing. And in fact, all the loads in your car, like your headlights, they're connected to the chassis of the car, the frame of the car. So these are all connected to one giant piece of metal, or one ground it's called. And that allows all the charge that goes through here to flow back to this battery, as it must for a complete circuit. So this is very convenient when you have a big circuit diagram, because then you don't have to draw a line that goes all the way back to there. You can just ground it no matter where it is on your circuit diagram. Showing a ground and having your negative terminal grounded means those two are electrically connected. Next up is series wiring. Series are where components are connected, so there is only one possible path for current. Flowing charges have no choice in series. All the charges flowing through one of the component in series must all flow through the other. So you can have, just in part of your circuit, you can have 2 components in series. That just means that every electron that goes through one of those devices also goes through the other. That's series. Here's an example of some light bulbs in series. Here's 1, here's 2, and here's 3, and I'll just go right back to the battery. Those are all in series. Now, parallel wiring are where components are connected so the path for current splits. And to be wired in parallel, it must split immediately. I'm going to underline that, immediately before the components. So flowing charges have a choice. And then the paths for the current join back together immediately after the components. To be in parallel, the current has to split immediately before the components, and then has to join back together immediately after the components. So we'll see what that means. I'm just going to draw a parallel circuit right here. We've got our battery right here. Here is one light bulb, and here's another light bulb. Both of those are in parallel. It splits right before them, and then it joins back together right after those two. So that is parallel wiring.